Alrighty guys, what is up? Daddy here again today, and I want to start by wishing everybody a happy new year. And I'd also like to thank all of my subscribers because I finally reached the 1K subs threshold about a week ago. So thank you guys so much for support. I really appreciate it. And now let's get into the topic for today. So a lot of people have been interested in a power, heat, and sound review for the Dell PowerEdge R720. And at least for us, we're going to be looking at it, excuse me, in terms of AI, ML, and DL. So this is basically just going to be a review of the different servers I have, how I have them configured, and then we'll be looking at power consumption, the actual wattage that's consumed on kind of an instantaneous basis, the heat that they generate, and then the sound. So all the things that you kind of need to consider before actually implementing these or bringing these into your home or office or whatever the case is. So without further ado, let's get into it. So the first, I just want to go over the specs so we kind of know what we're dealing with. So I have 3 servers. The first is 6J02, and this is just the end of the service tag for convenience. It has 2 Intel Xenon CPUs. This first one is at 300 gigahertz, so this is the fastest of them, and then each of them are 10 cores apiece. So that's 20 total physical cores and 40 logical cores. RAM, we have 384 gigabytes in this first server at 1333 megahertz. So, not super fast, but it is cheap and it's reliable. And all the slots are filled here with 16 gigabytes or 24 16 gigabyte sticks. As far as storage, I have basically 2.5 inch 1 terabyte SATA drives, which are set up in RAID 1. So basically that way, if I need to, something happens with the OS, I can just swap, or I'll have basically a whole second copy, and then I can, basically swap another disk in and then keep running with no problem. Or even more convenient is taking that out and putting it in a new machine to kind of seed it without having to transfer an image or clone or do anything like that. It's basically you always have a spare clone, so you don't have to start from scratch over again if you're setting up a new server. So that's something I've found is convenient. And then I have 3.5 inch 4 terabyte SAS HHDs. So both of these are set up in their own virtual drive, and this is set up in RAID 5, so just to provide some protection and a little bit of redundancy there as well. So I know it says 26 terabytes of storage. That's actually not the actual amount, but that's just the total amount that this provides, and I'm just providing a little context as to how I have everything set up. So it's actually going to be significantly less than 26 terabytes, and that'll be the case for pretty much all of the other servers. I've set them all up so that whatever disk has the OS on it, or the boot disk, boot drive, whatever you want to call it, is always set up RAID 1, and then all the other disks are set up for basically storage in RAID 5. So that's how I have things set up pretty much across all of my servers. I found it works pretty well for me. Anyway, so RAID controller is going to be pretty much the same across all of them as well. So this is going to be the H710. Most of the NICs are just going to be basically a standard 4-port 1 gigabit Ethernet, and then I believe one of them has also a 10 gigabit Ethernet, but I don't use that at the moment. My home infrastructure won't support it, unfortunately. And then finally, I have the 2 Tesla P100 GPUs in this server. So I use this server quite a bit for computer vision related work, and it seems to work quite well so far. I haven't benchmarked all the servers, but that's coming in a hopefully a video soon after this one. So this is server WKO2, and again, this is just the same thing as pretty much the other one. It's just an XD instead of just a regular R720. Has less RAM, has more storage, and has no GPUs. So, and this is the one that has the 10 gigabit NICs. But anyway, I use this mainly as a Docker container server, and then just for storage, because it's quite a bit of storage, but it's relatively slow. So that's pretty much the specs here. And then again, same thing. This is pretty much the or more similar to the first server. So this is 4x61, and this has the slowest GPU, has the most RAM. This is I got this RAM for a particular project, so I'm working on with the Bitcoin blockchain, and having this much RAM allows me to do things in memory without having to create databases or other different kinds of data structures. So this allows me to be a lot faster. So that's the reason for so much RAM. Actually, am almost maxing this out as it is, so I probably should buy more. But anyway, so this is for a particular application. That's why there's so much of it. And then I use this whole server for AI and machine learning around the Bitcoin blockchain. So it's got a good amount of storage. All of this is on SSDs, so it's the read and write speeds are the fastest, which is why I picked this server to work with the Bitcoin or with the blockchain, because it's so much data that those really make a difference. And then everything else is pretty much the same. The only difference here is we're using the P40s in this because they have more VRAM, and you can load bigger models into memory. So that's what we're working with. So just to kind of summarize, first server has GPUs, second server does not. It's mostly a storage server, but it has a lot of drives, so that might increase power consumption. And then this one has the P40 GPU rather than the P100 GPU. So those are really the major overarching differences. But before we get into the performance and the power consumption, I wanted you guys to understand why these servers may behave differently. Okay, so let's go ahead and get out of that, and let's go ahead and pull up the spreadsheet that I made, and we'll tackle this in three parts. The first part will be consumption, or basically power, and then we'll look at temperature, and then we'll look at sound. So this will kind of be part one of that. So what we're looking at here is basically 1 month. So I just took an arbitrary month. I started this kind of about a month ago. I bought some Casa smart plugs that monitor power consumption. I thought this would be a nice way to kind of look at this and then look at what the iDRAC says and see how accurate they are against each other. But anyway, in case you are curious and you would like to do this at home, these are the smart plugs I used. I'm pretty happy with them. The only thing is some of the functionality, like you can supposedly input your cost of electricity where you are, and it will tell you on a real-time basis how much you are spending each month in electricity. There's a bug in the firmware somewhere that is not accurate. Like it was telling me that I was spending like $300 a month on these servers, which I know is not the case. In fact, we'll show what the real calculated values are here in just a second. But anyway, so I have each of these plugs, and I'll show you downstairs in more detail, but each of these plugs fits on or sits between the main power input and then the power supply in the server, and it monitors the voltage per power supply. So really you need 2 per server and add them together to get the full consumption. Looking back, I should have used one plug and then split it out so that one plug would monitor both, but that was an oversight on my part. Anyway, you'll see what I mean in just a minute. Okay, so just in case you want to do that, that's there for you, and I'll link this in the video description. But so for the first month, as you can see, the total kilowatt hour consumption for each of the servers. So each of the servers is highlighted in different color, and this is each of the plugs. So each power supply and each of the servers has a 1100 watt like standard power supply for the Dell R720 servers, so each of these plugs is reading the power consumption per plug. And so all we've done here is we just calculated the monthly cost per plug, basically, and then the total per server. So as you can see, they're pretty much the same. I mean, this is a few dollars lower, but for the most part, the ones that are using... Oh, sorry. So the two that are using... No, actually, that's all. I had them out of order. So these two use the GPUs. So this one is using a little bit more power, costing a little bit more per month. And this is actually the server that I'm using for Bitcoin. Surprisingly, is using the least amount of power. And I think this is probably because the drives in this are SATA, all of them, so they just consume naturally a lot less power than the HHDs. So that's my hypothesis as to why this is so much cheaper percent wise. I mean, it's only a few dollars, but so anyway, in summary, guys, this is what it costs. It costs about $25 to run each server that I have, which in the grand scheme of things really isn't that much, especially if you watched my one of my last videos about the best machine learning rig for 2024. When you start comparing it to cloud-based solutions, or building your own custom rig, this really is a cheap price to pay per month, to get this much computing power. Now again, if you built one yourself, or if you paid per hour, this might actually be you might be able to get this down a little bit, but the problem is you won't be able to find this level of compute in any of those other scenarios. So $25 a month for this much compute is a pretty good bargain. So if we look over here, this is just mapping it out over the 30-day period. So this is the first server, and also each of these servers has been under load, or some kind of load, running at least one or two programs over the course of this month. So this isn't just like they're sitting at idle. So this is what I would consider, for me, normal usage. So I feel like these numbers are fairly realistic. But again, it depends on a lot of your other constraints. So for me, depends a lot on what your cost of power is for you guys. So for me, it's 13.47 cents. So just to show you guys, the average electricity cost in Jefferson, Georgia is 13.47 cents. So, take that for what it is. It may or may not be accurate, but this is just kind of a benchmark, to show you what it would cost to run these. So it's kind of interesting. Each of the servers looks a little bit different over the 31-day period. Fairly consistent, and there was a large spike here. I forget what I was doing on each of these servers at the time. It'd be interesting to kind of correlate the power consumption to what I was running. But this is the only one that I was just running kind of background programs. This was the least utilized over the month period. And as you can see, it just kind of oscillates between 6 and 6.4 kilowatt hours. This also has the most drives. This has like 16 HHD drives. So, naturally, it's probably going to consume more power. So that's just another thing to think about, is whenever you're constructing these, the more drives, and especially hard disk drives, excuse me. I always want to say HHD, but it's HDD. But anyway, the more of those you have, the more power you're naturally going to consume. Same thing with GPUs. And then also, your the complication and utilization of your machine are also going to add, how much power you consume. And this is another, I took all of the watts, so basically like instantaneous power consumption. So at each of these times, and this just kind of shows you, what and this is over yesterday. So this just kind of shows you, as you, I was running several things here, and as I would run things, you can see the spikes, in power consumption. Same thing here. I was running a couple things. You can see like when I start things and then what it looks like whenever it's kind of just idling, or I guess when it comes to kind of an equilibrium. And then same thing here. So it's just kind of interesting to look at, what happens when you are actually running programs. And for me, the difference is only about 15 or 20 watts here, 30 watts here. I don't know what I was running here, but that's pretty significant. It's almost 50 watts. But anyway, you guys get the point. You can use this to kind of monitor how much it actually costs you in terms of watts to run, a particular program. So this could be pretty useful. And again, all this data I got and just dumped out from the CASA monitoring app, and that's what you're seeing here. Okay. So now that we've gone over this, I also want to show you. So in case you don't want to buy these plugs, you can also, if you have access to iDRAC or you have it set up, you can also go in here and you can look at power and thermal, and this will give you a lot of other good information. So for example, for the last week, this will tell you, average watts consumed. So you could look at it by day. So, you guys kind of get the idea here. You guys, you could use this and dump this information out. Actually, I don't know if you can. I don't think you can dump this out. You can dump the temperature information out. But anyway, this will help you monitor. You could basically look daily or weekly and kind of get an average, of how much you're consuming. And then you could calculate out, what your monthly consumption is in kind of a rough way. I think the CASA plugs actually do a better job, of this, but this is also there for you if you wanted to go this route. I know that a lot of you guys probably want to know what power consumption would be at max load for if you're using both GPUs. So I decided I'd show you guys that really quick. If you look right here, as you can see, I just wrote a program, just something quick, to basically get 100% GPU utilization, and it spiked all the way up to about, looks like 360 watts. So if you want, just show you guys. Okay, so I'm logged in, and I went ahead and made a folder. So this is the 6J02 server, so the one with the two P100s. Unfortunately, I'm running something on the one with the two P40s right now, so we'll just use this as kind of a gauge here. It should be similar across both. But basically all this does is create some large matrices, and then splits a process, or using multiprocessing assigns a process to both GPUs, and then just has each GPU run these computations. So when we run this program, it should max out the GPU. So let's go ahead and go back over here, and let's run this guy. And now let's come over here and let's take a look. All right, cool. So as we can see, we are now utilizing 100% of the GPU. We'll also let this run for a bit until this temperature kind of stabilizes, and we'll see how hot these GPUs are getting when we're running as well. And then we'll look at what the kind of the average exhaust out of the back is, and then the max exhaust from a temperature perspective. So all right, let's take a look. So now this should, if we're looking at an hour. So all right, so that came down. All right, so let's go to power and thermal. All right, okay, so I just barely tested this, so I didn't let it, run for very long. But as you can see, we're actually up here over 400 watts now, which makes sense because we were at about 35 watts a piece, and now we're at about 200 watts a piece. So really, it should actually be closer to probably to like 650, 600-ish watts. So we'll just give this a minute and we'll let it stabilize. Alrighty, so things seem to have stabilized out here. It looks like we're hovering right at around 400 watts for sustained use, and there was an instantaneous spike up to about somewhere in between 460 and 500 watts. So it looks like, at least for the P100s, we can safely assume that we're going to be using about 400 watts sustained, depending on what the CPU is having to do as well, maybe a little bit more. So kind of a benchmark if you're fully utilizing your GPUs, what you could expect as far as power consumption goes. And I'll post the script out there so you can run this yourself. So once you get everything set up, you can test this and see what you can realistically expect when you're maxing out GPUs for various use cases. All right, guys. So at this point, the GPUs should be getting nice and warm. So let's see where we're at with that. All right. So it looks like they've been holding around 81 and 79 respectively. So I'll continue to monitor this to make sure that they don't get any hotter, but the maximum operating temperature for these GPUs is about 85 degrees Celsius. So this isn't wonderful, but it's within tolerance. So you won't be damaging the GPUs by running them this way. But definitely something to consider for as far as heat is concerned. This will probably add a lot of heat exhaust into the equation with these things running so hot. But just one thing some things to consider for GPUs in the server. You can also I heard one suggestion, you could put some snail blowers in the server to kind of cool these down, and you can also adjust the stock fan settings higher so that these run cooler. So those are some things you have at your disposal if you're uncomfortable running them this close to the maximum operating temperature. There we go. So let's move back in and let's look at what the internal temperatures are for some of these for these servers here while we're up here, and then we'll go downstairs and we'll actually use a heat gun or use a laser thermometer to see what we're really getting out of the back of the servers. So hopefully that'll paint a clearer picture as far as what's theoretically happening and what's being measured with instruments, and then what we actually observe with a real thermometer coming out of the back of the servers. So okay, so this is the one that we just started running, or we are running the script for the GPUs to keep them at 100% utilization. So as you can actually expect, these should be running a little bit hotter, or the temperature should be running a little bit hotter. So the good news is downstairs it's really cold today, so it's probably about 60 degrees. And the exhaust temperature is only 87. So, that cool air, the cool intake really helps, really cool everything down and keep the internals of the server pretty cool. But if you look, you can see the average here. We're averaging about, this is last year. Let's look at this month. So monthly usage, we're averaging about 17 degrees Celsius. So 17 degrees Celsius would be about 60 something. So 17 degrees, 62. And let's look at today, see if it's creeping up at all. So it seems like on average, so what this is telling us here, the system board inlet ambient historical temperature, there's a sensor gauge. There is a sensor, or I guess I say a temperature gauge in and around the motherboard that just measures the ambient temperature there. So that's what we're getting here. So the ambient temperature over the last 24 hours around our motherboard has been about 60 something degrees. So, to me that seems a little bit low, but that's what you're seeing internally. And then the exhaust temperature, at least at the moment, is supposedly 87 degrees. And then this is what, ideally the ambient temperature of the room should be. So we'll definitely check on that. And also you can see the max, as far as what they can operate under. So we are well within the tolerances here for each of these things. So next we will go downstairs and we'll actually look at these physically. We'll look at what's coming out of the back of the servers, and just to show you the others, this is basically running at idle right now. So GPUs are about 100 degrees. The exhaust is about 95, and then the inlet again 62. So that's consistent. And if we look at today, let's go back to power and thermal and temperature. So yeah, nothing really changed still. So CPU is about 100 degrees a piece, exhaust is about 95, and inlet temperature is about 62. So that's consistent with the other server. Average here is about 17 degrees. Of the month-long averages, looks like it's about 17, 18 degrees, somewhere there. And then we'll look at the last server. And this one is the one, so I'm not utilizing the GPUs here, but I am running some fairly intensive programs on each of the CPUs. So looks like these are maybe, temperature here is a little bit elevated, but not much. Exhaust temperature is only 80 degrees. And then the inlet temperature is, approximately 60 degrees. So fairly consistent. And then let's look at today. So, okay, this is a little bit cooler. So we're looking at about 15, 16 degrees. So, and then let's look at last month. So again, 15, 16 degrees, somewhere there. But yeah, so that's what the sensors are telling us for the servers. But for a lot of you guys, it's really going to make a lot more practical sense to know what is the exhaust coming out of the back of the servers. I would consider this pretty standard use. So this is at idle, this is running stuff in the CPU, and this is running GPU at full blast. So this is, I guess you could say, a fairly good mix from coming out of these servers. So if we go downstairs, what's really coming out of the back should be a pretty good gauge as far as, what you can expect at home on a really, average basis. So, okay, next we'll go downstairs and we will do a physical temperature test. All right, guys, so here we are downstairs. Next to the servers. So first thing I want to highlight is you can see these CASA plugs. So these are the same things that I showed y'all earlier. And basically what's going on is each two of these go into the two 1100 watt power supplies. So each plug is representing one of those power supplies. So here we go. This is a good example of what things might sound like if you were to have this in your room. One of the servers is kind of spooling up here, just from a sound perspective. But anyway, so let's start with temperature. So this has basically been sitting down here pretty much all day, so it should be pretty much the exact temperature of the room. So we're looking at about, call it 65 degrees, give or take. I also have a little temperature gauge right there next to the outlet. So that's another point of reference, and I'll check that in just a bit. But basically, what I'm going to do is I'm going to use this temperature gun, and I checked it against this thermometer yesterday, and then that temperature gauge as well. And the temperature, so the Giove temperature gauge there and then this physical one were within 1 degree of each other. So I'm relatively certain that those are calibrated. And then this was about 3 degrees off of that. So, take these with a little bit of a grain of salt, but it should be fairly accurate, what I'm about to tell you. So what we're going to do is, to make things easy, the 100 watt or the 1100 watt, I guess you could say like little dots, are pretty good solid points that this thing will be able to register against. So we're going to measure each of those for each server and see the difference in temperature, coming out of the back. But really overall, just in general, this should give us a decent idea of what the exhaust temperature is really going to be for all of the servers kind of put together. Before we do that, I just do want to add one piece of context. So one of the things for me why this isn't really a huge factor is because I am in like a 2,000 square foot basement. So, for me to have these 3 servers sitting over here in the corner really doesn't affect the temperature hardly at all of the overall room. Especially since it's really so cold out anyway. It pretty much just stays at 65 degrees, regardless of these being here. But if you were going to store this in a closet or something like that, you would really need to be careful and think about how you do this. So, all right, what we're going to do here is we're going to look at the top server. So the top server is the one with 2 P40s in it. So let's take a look. Okay, so that's 98.1 degrees. All right, so we're gonna look at server 2 here. I know you guys really can't see that well, but there we go. Okay, so that's 106 or 100.6. And then we'll look at the bottom guy. And that's 102. So the 102, so just for reference, the bottom server here, so this guy, bottom, that is the one with 2 P100s that's running at full blast right now. So ideally this should have the highest exhaust. And again, okay, I was only 90. It seems strange. There we go. Yeah, I just had a weird angle. So yeah, it's like 103. So anyway, you guys get the idea. But really, it's exhausting, it seems, at about 100 degrees, regardless of what's really happening internally. So you can use that as a pretty good benchmark for what kind of exhaust temperatures you can expect. Now again, take this with a little bit of grain of salt because the ambient temperature here is about 65 degrees. So, even when it's exhausting out, it's pretty quickly getting, getting cooled off by the fairly cool air that's around it. But I hope this gives you guys an idea of what's really coming out of the server. And then, if you want, you can look at, average fan speeds for your particular server, and then, like what that flow rate might be, and you can actually calculate, you can get as fancy as you want with it, calculating, how much heat they're actually going to put out, in your space. And you can run some calculations to see if that's, really going to actually work. Now, for me, I don't really care to get that fancy with it. I would just say I'm kind of more of a try it and see kind of a guy. So I would probably put it in there and see. And if I start getting temperature warnings, then, you could figure out a better exhaust system, like maybe plumb some air in from a window, or, something like that. If you only have a limited amount of space, or you can only put it in a closet or something like that, you might have to get a little creative as far as how you exhaust the heat. But that should give you guys a pretty good idea of the heat part. And now what we'll do is this is how they sound normally. It's really not too bad at all right now. It's really quiet, even though 2 of the servers are running under load, and one of them is pretty much at idle. So this is the 2 P100s. This is the 2 P100s. This is the server with no GPUs, and this is the one with P40s. So just for reference, and this is under full load. This is under full load. This is just running stuff with the CPU, and then this is basically at idle. So this is an example of how it would sound, and then just to give you a full example of what it could sound like at max, I'm gonna turn this off and turn it back on, and this should tell you basically the max volume that they can be. So again, not horrible, but probably not something you want to have in your bedroom, or someplace where you're going to be spending a lot of time, because it does get a little bit annoying, especially if the fans start kicking on and off, and it can be a bit of a bother. So, well, all right, guys, that pretty much does it for this video. I hope you guys found this helpful. If you have any comments or anything, or anything that you'd like to see, please just leave me a message, and I will try to answer your questions the best way I can. Thank you guys again, and I'll see you in the next one. All right, guys, brief reminder here. If you enjoyed the content, please consider giving me a like and a subscribe so I can continue to grow and produce better and better content for you. If you really enjoyed the content, you might even consider buying me a coffee, and the link for how to do that will be in the video description below. If nothing else, please just give me some feedback in the comments and let me know how I'm doing, if anything's unclear, or if there are anything that I can improve on. Thank you again, guys, and have a great rest of your day. Bye-bye.